Good morning. My name is Ben Kaffes. I'm a principal architect at Insight, and I work on our enterprise strategy team. Today, I want to talk about the 3 smart manufacturing use cases that are creating cost reduction. And I'm also going to talk about a number of different case studies from clients that we've worked with. So as we think about some of the trends that we've seen in manufacturing after COVID, we're seeing opportunities to continue disrupting technology and introducing technology to create disruption so that folks can get better operational efficiencies. Of course, the less certain economic outlook is forcing everyone to look at additional efficiencies. So these 3 use cases start with overall equipment effectiveness. So what does that really mean? Well, you've got equipment out there and it's maybe, it needs to be lubricated every so often, or it has parts that wear down and they need to be replaced. The important thing to do is be as predictive as possible when it comes to those particular challenges. And you want to understand how your equipment can be most effectively giving you as much output as possible. So you constantly will be interested in getting data about that. So what is that? How do you actually achieve this effectiveness and really getting the efficiencies out of these systems? And the way you do that is really start to look at behavior. So if you imagine you're taking all of this information from a piece of equipment like vibration readings, maybe temperature readings, and you take that data and you start to, over time, evaluate that against when you have outages. And you use that data if you see the vibration speed is changing and it becomes gradually less efficient because of increased vibration, for example. Well, that means that your equipment that's kind of an indicator of less efficiency. And so having the information to do that trending and take a look at that data and then analyze what the outcomes were from those readings, you're actually going to be able to kind of predict outages proactively. And what that means is that you can not only have your maintenance staff make the appropriate adjustments and repairs ahead of time, but you can schedule them more intelligently because you're not as reactive to something breaking, but you can be proactive. So some of the opportunities in this space are going to be about kind of making sure that we're collecting as much of that data as possible. We have the right sensors involved, and we are doing that analysis in an efficient manner. We don't necessarily want to just capture every metric in the aggregate. That's a lot of data that maybe doesn't have a lot of value, but you can do some analysis and kind of aggregation maybe on the edge or in the industrial computing environment so that you get the appropriate kind of metrics out of that in the aggregate that provide that information. And then you can do those predictions, have a lot of that data. So these are some of the first use case that we wanted to talk about today. The next one is process automation. So using things like computer vision is a great example where you have equipment that, or you have something that you're producing and let's say about food, for example. You've got some food that you want to make sure that the colors look right or the ingredients match the label. Those are the types of quality control. Those are the types of things that we do from a QA inspection standpoint, where computer vision can actually do that analysis for us using AI models that are again running on the edge. You can take a camera and look at an image, and you can get inferences from that image to understand, whether that is appropriately matching what that particular product is supposed to be like. So that's an area of opportunity that people are starting to really latch onto. We're seeing active use of things like computer vision, thermal. I'll be talking about a use case around thermal imaging for exactly this particular problem in a moment. So I'll get into a little more detail on that. But that is another use case is using that kind of automation to do the analysis on the quality of the product that you're producing and using intelligence, AI, using technology to actually do that automatically as opposed to having human eyes on it that, may miss something or, just are hard to find the skilled people that can do that. And then lastly, we have kind of nimble and agile responsiveness through faster decision making. So this comes down to really providing the visibility of everything in the aggregate. So some people might call it like an operating picture, or even just getting the right analysis and the right information at the right time. So in traditional computing, you're pulling in a lot of data, and you might take maybe a daily batch or an reporting run into your data warehouse, or a monthly reporting run, and that makes sense still in certain circumstances. But sometimes you need to react and make adjustments more quickly, and because of that, you want to have tooling that can help give you that information right when you need it. One opportunity would be, an example might be using Teams to provide visibility through dashboards and Power BI to make decisions about, whether you want to take a piece of equipment out and do some maintenance on it based on maybe the schedule utilization for that particular piece of equipment. Having that information right in front of you so that you can make that decision quickly, and also avoid taking and lowering the utilization of that piece of equipment, is an opportunity that really has a lot of value and a lot of ROI for an organization involved in manufacturing. So really it comes to how you can enable this is by providing integration between all the different systems, maybe the manufacturing execution system, the ERP system, maybe a warehouse management, having all of that, come together with integration. So all those pieces are visible in a common window, something like maybe Power BI, or maybe a custom application that was developed to provide that common operating picture of what is happening at any given point in time, can help folks make decisions. And so the reason that this has become a need is there's so many great platforms out there, and so many great solutions, software suites that folks are using in these environments, but they don't necessarily integrate terribly well all the time. And because they're disparate organizations, sometimes the best of breed, in this particular software suite may be from a different organization than this best of breed. And so they don't necessarily have any interest in integrating well together. And so, organizations are kind of on their own to build that. And of course, because every organization is different, their needs are different. And so sometimes the off-the-shelf solutions can't entirely meet the needs. And so having that information to make those decisions with, data that's well integrated and provides high visibility of the appropriate information is an area of opportunity and a use case that we wanted to talk about today. So now I'm going to get into some of our case studies in manufacturing. I'm starting with actually something I just alluded to a little while ago. This is a die-cast manufacturer that makes outboard motors for boats, and they had a particularly difficult problem to overcome because they had, as you can kind of imagine with engines, you have a lot of components that you're putting on kind of this core die-cast. And eventually, you've got all the components in there. You fill it up with fuel, you start it up, and you test it to make sure it's effective and it's got it doesn't have any cracks in it or anything like that. The problem is once you've gotten that far down the line and you've added all those additional components, that takes a lot of time and energy to kind of put all that in there just to find out maybe there is a problem, and you have to just throw it on the scrap pile. So this organization was interested in avoiding that by using thermal imaging to find those defects early in the process. And so we worked with them to help them kind of operationalize an AI model that they had in R, which is a programming language that a lot of data scientists use. And they took that thermal image and did the analysis on that, and then would do an inference using that R model to make a decision whether that die cast was good or if it was defective. And so by operationalizing that on the edge, we didn't have to use a terrible amount of bandwidth and make a round trip to the internet every single time. We were able to do all those inferences locally on that local area network using a virtual machine in this particular example. And then that was on their kind of operational network. And then as the inferences came about, we were able to actually integrate directly with their PLCs using OPC UA. So we were taking these thermal images through OPC UA, and then if we found a bad die cast, we would actually have a light that was either red or green, depending on whether that was a good die cast or a bad die cast. And so the operator on the manufacturing line would see that and be able to react to it appropriately. And so they had visibility of that through an application that we built in one that runs on the edge and then one that runs in the cloud, so it gives them the appropriate visibility where they need it. And that was enabled using Azure IoT Edge. Another case study that we have is in an oil and gas company. They wanted to monitor their pumps and be able to kind of prevent equipment damage in kind of extreme environments where the temperatures were very, very high or very, very low in certain areas. And we had to have something that was ruggedized. So we did partner with a company called Moxa that had a piece of hardware that was ruggedized specifically for this type of a use case. And we used Azure IoT Edge based containers using their Azure IoT Edge solutions that we were able to build an AI model in Python that would actually do predictions when the oil pumps were going to fail. And so it would pause the operations and prevent the failure, and then of course create less damage and provide just overall higher uptime. So the value of this, and really the last use case is just less manual work to do later, and just increased operational efficiency talked about a little bit earlier. So again, we're seeing a theme here of kind of using some compute on the edge and using AI to do these inferences and make these predictions. This next case study is a company that made HVAC equipment, and they wanted to be able to kind of have better visibility of everything that was happening on their equipment. And so we used Azure IoT Hub to ingest a lot of data into our platform, and then that was used to provide that visibility. And again, in this case, we wanted this had to do with a lot of the maintenance on this equipment. So having all of the visibility of the readings of these different sensors, like temperature sensors and vibration sensors, and having that surfaced into a central cloud platform allowed them to make decisions about maintenance. So when you think about what a maintenance person needs to do in an organization that has staff like that, they have to think about how do they schedule these folks. So you can react to emergencies where your scheduling is completely on demand and very inefficient, where folks may be flying all over the country to make these errors, or you can have things proactively, and predictively understood. So if you think that, okay, this equipment has, probably 3 months before it fails, so that means we want to replace these parts. And so if you schedule those as part of the preventive maintenance, well, now your repair staff is very effective and efficient because they can, make those schedules close to each other. They can go to one of your clients and another one of your clients that are close by, and you can get the most bang for your buck from a timing perspective. And honestly, it's just, better overall livelihood for those folks. They don't have to travel as much and kind of just go from one extreme to the other. And of course, there's always emergencies, but reducing that and being as predictive as possible is a highly desired outcome. Getting into some of our other use cases, we have a generator manufacturer that was trying to reduce their cost and overall scrap. And so they had an assembly process that with manual visual inspection steps, where someone had to actually look at this generator in order to determine whether it was good or bad. So because of that piece of the process was visual, they took a lot of manpower to do that. So instead, we looked at a solution using computer vision and AI to identify and flag that the windings in the compressors and find those defects before the subassembly was before the winding step. So they basically could take a picture of that using a mobile device and do that computer vision analysis, and that would then do the right prediction, and they didn't have to rely on somebody's eyes anymore to actually do that inspection. And so the qualifications of the person doing that inspection was then, it was easier to find folks that could actually do this work, because they didn't all have to be qualified to make this visual inspection anymore. They just could use this app to do that and do that computer vision inferencing. We also have another case study here where we had a recycler that wanted to use AI to improve on-the-job safety. So in this case, we wanted to identify dangerous items as this crane was looking for scrap or sorting through scrap. We had the computer vision identify these dangerous items. And what this allowed them to do is just have less damage to these cranes, because these cranes did not have to, weren't trying to pick things up that were either too heavy or potentially dangerous or erosive to the crane. And so we put a camera on the crane itself, and then we did some inferencing on the edge using Azure IoT Edge to do those determinations. And using those inferences, we could make decisions about whether this crane should try to pick up this particular item or not. This case study on the right, as you see someone holding a tablet there, this was an inventory management solution that we had a client was interested in reducing manual cycle counts. So they had a big warehouse, if you can think about the Indiana Jones kind of at the end of that first movie, where they put I think it was the Ark of the Covenant in this enormous warehouse. Well, this is kind of the size of the warehouse that this organization has. And so you just, as far as the eye can see, you're seeing shelves and materials that they ship out. So going through there and manually looking and counting every box is very painstaking, and it is error prone. And so the goal was to find a way to actually use computer vision to do the cycle counting, which we've done in a couple of other scenarios as well. The problem is that there's only so much data available to train these, and there's only so many different permutations of kind of the layout of these particular palettes of materials. And so what we ended up having to do was using generated images using synthetic data, so that we could train models based on the basically assumed permutations of palette configurations. And so by building those out synthetically, then we could use a computer vision model to train it based on those synthetic images. And then when it got into the real world and somebody took this tablet application, they could scan this palette and do the inferencing on which actual materials were there and what their cycle count was. They also used optical character recognition to actually get the skew of the actual boxes, and so that's where the counting came into play, with figuring out how deep the pallets were, how many boxes were on there. Now, in addition to that, there's also the assumption, and you have to, the business case has to provide the clarity around this. But in this case, the pallets were always going to be the same skew as you looked at. So you have the skew, it's going to have on the same pallet, anything behind it would be the same skew. So certain rules like that we had to have in order to actually accomplish this. But fortunately, in this organization, they had those limitations already in place, and so it was something we could work through. Is here, or case study, I should say. When we think about the nimble and agile responsiveness, here's a great example on the left of a manufacturer that was using a digital twin to do analysis of kind of the fastest path in their manufacturing process. So by seeing kind of this aggregate vision using an ontological model and a digital twin, there's all these, there's all these pieces that are moving through the manufacturing process in order to get from your raw materials to your finished goods. And so starting with those raw materials and the different pieces and the different stages in there, in the aggregate, it makes a lot more sense to a computer to look at all this data and say, you know what, this really should be moved over here. You should change this, happens before this one and after that one. And making those small adjustments had a dramatic impact on the actual ROI. And as you can see, there is a 15x ROI on this particular case study, which is great. And it's really interesting because it really just was data. If you're not familiar with kind of how digital twins work, they're capturing data in what I mentioned before as an ontological model, which is something that's representative of physical space or some other type of relationship, and data is stored based on those relationships. So like in a traditional column and row type of database, things are indexed, just based on keys and how you define those indexes. In a digital twin, those are actually stored based on how close things are to each other in physical space. And so when you're searching through the digital twin, it's more efficient because of the way that relationship is represented. If you're familiar with graph databases, it's a very similar concept. This next case study is a PC board manufacturer, and they needed to be able to kind of provide some guidance to equipment technicians when there was a problem and they needed to fix something. So as you look at different solutions, we used a HoloLens with an iPad and a basically remote assist type of solution where someone was observing this particular person trying to repair it. And just imagine somebody on a PC board with a soldering iron or something like that, and they're trying to make this repair. Someone would, from somewhere else in the world, would be able to essentially shadow this person using remote assist, and they would look over their shoulder and basically say, okay, these are the points that you want to solder. And there was way more clarity than there would be if you were just using your phone to take a picture and do like a Teams call or something like that, or if you were just taking still pictures and sending them and kind of working back and forth that way. So it streamlines the process really well to use something like HoloLens for remote assist, and it obviously saves a lot of money because you're not having your repair people fly all over the country to make these particular these repairs. They can just help someone that is capable on site with a little bit of guidance. Our last case study is a industrial manufacturer that made compressors. And so this is somewhat similar to the HVAC use case that we talked about before, but we used a Power BI dashboard to provide visibility using Azure IoT Hub and streaming analytics. And using Power BI, we were able to kind of provide the right visualization centrally so that they could do the appropriate analysis and get better clarity on the overall efficiency of these compressors and areas for improvement out in the field, based on different variables like temperature, ambient temperature, and maybe power stability, power sources, different voltages. They could get a lot of that information much more quickly because it was all coming in real time. And so this is a case study where Azure IoT was able to kind of provide a relatively turnkey kind of solution that someone could quickly get that information and make some good analysis and the long-term analysis of the overall efficiency. So that is the presentation today. I appreciate everybody joining. Opening up the conversation for any questions.